Hello, Dr. Mike here for Introduction to Computer Forensics, my CIS-2808 class. This is topic 11, typically week 11 at the time of this recording, and it is about tools, specifically data carving and recovery. Also with a look at images more in depth. So this goes along with our textbook, chapters 3 and 8. Textbook itself for chapter 3 is a section on carving, and we actually go into the tool section itself called Foremost. Now I'm not going to go into the tool a lot. Actually, I'm not even going to run the demo of the tool. The net lab for this week, again at the time of this recording, has you running both Scalpel and Foremost. These are fantastic tools. The steps in the lab are really going to go ahead and walk you through how to configure the configuration file. These are both command line tools, and actually you use a great well-known image in this lab, and you carve out all kinds of stuff, Word documents and so on. So Scalpel and Foremost. Foremost, again, you look at the Kali Tools page, you can get information about it here. I believe the Foremost home page is pretty small, not much there. You can see the information here, latest version found here, which I think goes to the SourceForge. You can download it from there. It runs on a few platforms. And you can see some information here about the help out itself. So again, normally you just saw with Foremost, you're gonna set up a config file, edit what you want, and where you want to output the stuff to. So, and what image you want to parse. SleuthKit actually comes bundled with something called Scalpel. Very similar, also great for carving files. This is the GitHub page for the SleuthKit Scalpel fork of the binary. I believe there's actually a different GitHub page for it. You're not going to get into the ins and outs of it. You'll see it in the lab itself. Again, really great, both great tools. The lab's going to walk you through step by step of actually carving these files up, and find what you need. Definitely use these. Look at these tools, because the other part of this week's lab is image parsing. It's called the Rhino Hunt. So this topic 11 has you running something called there we go, topic 11. Rhino Hunt itself. So you actually have to download a zip file and carve out, there's 4 specific images, 2 GIFs, 2 JPEGs. So you got to run Scalpel or Foremost, or you do it manually if you want, which I'm going to show you how, but I would suggest definitely using the tools also. Or at least use the tools first and go back, and maybe if you want to try and manually carve these file images out, go for it. But in any case, the images themselves. The reason why we want to go into images as part of this week also is image data, and I touched upon it a little bit the last topic. We looked at file information, metadata. We saw with images like JPEGs, a lot of information packed in those images. So, if we get into that, let's talk about what carving is, how it works, and that's what I'm going to demo is really how carving works, how these tools operate. There's two main types. I think there's probably a couple other you would list out, but 2 I want to talk about is header-footer carving and then structure-based carving. So I'll demo a header-footer. It's pretty much the easiest way to carve stuff out. Structure-based is a little more work. I'll do this within a hex editor on my demo here, but we'll talk about both. So first off, really you're looking at most basics here, as it talks about in the textbook. It involves searching a data stream for certain file headers, magic values, and determining or guessing the file endpoint. So it is a guessing game a lot of times, especially with structure-based carving. So again, you can see why the tools are definitely the best things to use for this. So there's some information on Foremost in this chapter, and then chapter 8 on file analysis has a section on images. And again, we talked about images before. But definitely look at this. There's a lot of information about images here. There's identifiers, tools you can extract data from your images, like the EXIF data. extraction tool I demoed in a previous video. JPEG definitely being one is known to hold information about when this picture was taken, date and time, GPS coordinates, things like that. So as you can see, a lot of information is packed in these images, GIF images and so on, information inside there. So PNG and TIFF. So again, image files definitely a cornerstone for data carving. Excuse me. Okay, so we'll move on to actual carving itself. So let's talk about heterophoto carving. So what it really means is heterophoto is we have those file signatures. And I mentioned it before, we actually have a database you can go to. You can see here, file signature database. So if I search for the extension JPEG, I can try it up here. We have the signature FFD8FFE0. So if we look at more in depth though, and this is a filerecovery.com post, which is actually pretty informative. JPEGs are going to be a heterophoto carving because it has the FFD8FF. It doesn't have a length embedded in it. It has a footer called FFD9. So knowing that, we can find and pull out a JPEG image from anything from a disk image, even from let's say a Word document. You can open like a Word document in a hex editor and extract the image out. So we'll actually look at that here. Now, before we jump into that, let's actually talk about the other part. And then we'll actually do a quick demo on heterophoto carving and how it works. But we can see here, this is more of a structure-based carving. So this is a entry for a BMP bitmap image. And we do have there's a header. It starts with a signature 4U24D. And then after that, we actually get the size of the file, the next 4 bytes here. So our offset of 2, after we go to the first 2 bytes here, we have these 4 bytes, and it tells us the size. And how does that work? It is in hexadecimal. It is a little Indian. So again, we start from the least significant bit and backwards. So 0000, 04, and then we got F6. F6, if you convert that, it's 1270 bytes. So it tells you how many bytes out from the header, I believe. And again, from the position of the BM header itself. And that's the BMP file. This is very common in a lot of file structures, and it's where parsing gets really a lot more obscure is not everything is always in one spot. So you can use file allocation tables to determine the initial file, and then it might actually have parts of the file later. So file carving can be a challenge, even for tools. But that is really a quick look at sort of the structure-based, real simple example of a structure-based file carving. And different files have different structures to where the file size resides. So now we'll go back to JPEG and we'll do a quick example. So again, JPEG is going to be a header-footer type carving. So how does that work? So using a tool like, let's say, Formotion Scalpel, what it might do is, let's say, example, we have this USB drive here, a DD image. It's open right now in this tool. This is a basic Bless hex editor. In case you're curious, Bless 6.0. This is on my Sans SIFT workstation. So I'll open this basic search function. And we're going to search for hexadecimal. We're going to search for that file header, so which is FFD8 FFE0. So we'll find that. And we found the first entry of that. And you can see also in the ASCII output, you see JFIF a few bytes over. I'll usually indicate it in ASCII there. This is our file header. So what we want to do is we want to get this offset, this byte offset here, and then we'll use the hex byte offset, which is 42404. So we're actually going to start here, 42404, and then we want to find the end indicator, which was FFD9. So search for that. and we get the file offset for this, which we have as 85354. So actually we want just the basic offset, so 353. So we want the end itself. We don't want this byte. We want this byte right here. So again, if we go back, it's nice that it keeps that in our history. So again, there's our previous entry. We want our hexadecimal here to be at the beginning. So we want the beginning of the file header. We don't want to carve out the file header when we carve this. We don't want to start after the first 4 bytes. We want to start at the first byte of the file header, including the file header. So again, this offset is an hexadecimal 42400. So what we're going to do is, using those offsets, I made notes of them down here. We're going to go ahead and do a select range. Now we're going to select our range. We're going to have to put in hexadecimal, so we're going to do 0x, which is our hexadecimal indicator, 42400, and we're going to go out to hexadecimal 0x. That was 85353. We're going to grab that selection. So it looks like we got the right selection there. One way to find out is this. Edit. I'm going to copy that selection. I'm going to do a new file and paste it. And then we're going to do a file, save as, and we'll put it in our carving demo here. And we'll call it extract.jpg. And we'll save it. And if we got it right, there it is. We extracted the image. So that's really how sort of the basics of header-footer carving works. I'm not going to demo. It's a lot more complicated when you start getting to file sizes. You got to compute the bytes out, and if the file is fragmented beyond the, in several parts of the disk, it's written out in several blocks. It can be a lot more intensive. So this is a very simple demo, very easy. I was able to grab the whole file in one block and get the image itself. So again, if this was an actual image, we can see image properties. If it had any kind of EXIF data, we can use that then. So again, take the extension of that. You can go further on. So again, if I was extracting this manually, I'd want to make notes of how I did it, what tool I used, what version of the tool I used. I probably want to maybe also get an MD5 and file name, so I can get a hash of this image. Again, let's say this would be a copy. This drive would be a copy of the original suspect's drive image. Again, with matching hashes. So again, we're still following that process of working on a forensic copy of the suspect's artifact, in this case a USB drive, let's say, and then manually parsing that. So in reality, that's a pretty long process for one image. This thing was full of images. I really would go and point scalpel foremost at this and then set the configuration file for JPEG, GIF, BMP, just all the images, and dump them to a directory. You will do that in the lab. That goes along with this lecture. So, but again, I really want to go back to how that works. Again, a quick summary. That was a header-footer carving, looking for the offsets. Based on the file header and footer signatures, which again you can find information for file signatures like in the database here. The other one is structure-based, and again it tells you where the file starts, and then in the file, in the header of the file itself, somewhere depending on the file format, will have the size of the file. So that's another way. So structure-based carving. So that's it. That's a quick demo of how file carving works, and hopefully you'll get your hands in there and use Foremost and Scalpel and see how nice it is. They're fantastic tools, and it'll be very useful for this week's labs. So that is all for the demo. Thank you for watching.